It is an enduring mystery that has confronted astronomers for decades. Why do comets, nature's so-called dirty snowballs, sometimes erupt with activity or even explode at vast distances from the sun, much too far to attribute to the gentle effects of solar warming? Comet activity has now been observed at up to 2 billion miles from the sun. That's right, I said billion, where the average temperature of space is about a few hundred degrees Fahrenheit below zero. Such was the case with the comet C2017 K2, which was found in archival data to have developed a coma while between Uranus and Neptune in 2013. In 2017, NASA's Pan-STARRS telescope observed the comet's activity at 1.5 billion miles from the sun. Recently, astronomers using the ALMA telescope have observed activity in the comet C2014 UN271, as it was just inside the orbit of Uranus, at around 1.5 billion miles away. The comet is legitimately enormous at about 80 miles across, and is described as a so-called pristine Oort cloud object. The Oort cloud is a hypothetical, never observed, shell of icy bodies that is proposed to exist in the farthest reaches of the solar system. Nathan Roth, the lead author of a paper in the astrophysical journal Letters, says of the findings, "These measurements give us a look at how this enormous, icy world works. We're seeing explosive outgassing patterns that raise new questions about how this comet will evolve as it continues its journey toward the inner solar system." However, in the paper, the authors do acknowledge the unexpected nature of the comet activity, including the apparent production of carbon dioxide at such an enormous distance from the sun. They state, "Evidence for CO2 at such large hill radius is surprising and raises the possibility of CO production through CO2 photolysis. Understanding the nature and origins of activity in this distant active object requires a detailed investigation." Unfortunately, for such a, quote, detailed investigation to produce any meaningful results, an overdue acknowledgement of countless paradigm-shattering discoveries in comet science is first necessary. Number one, and most obvious, is that the description of comets as, quote, icy bodies denies an overabundance of objective scientific data. Every comet nucleus image to date resembles a portion of planetary desert blasted into space, desiccated, rocky, and defined by shockingly complex planetary geology, including sand dunes, mesas, cliffs, and sharply cut terrain. This includes the comet Wild 2, which was chosen as the target of NASA's 2003 Stardust mission precisely because it was thought to be a, quote, pristine ancient object, which would be covered with abundant ices. This was described as follows in an official pre-mission press release. Why visit an obscure, hard-to-see object like Wild 2 when there are so many more notorious comets to choose from? Number one, it's fresh. Before its near miss with Jupiter in 1974, Comet Wild 2 was well preserved in the frigid outer solar system. With its new orbit, Wild 2 now comes much closer to the Sun. When a comet passes close enough to the Sun, some of its material is boiled off into interplanetary space. Since Wild 2 has passed the Sun only a few times, it still has most of its dust and gases. It is pristine, end quote. Of course, as you can see on your screen, Wild 2 looks nothing like a pristine, dirty ice ball, a fact confirmed by analysis of the comet's dust material. Indeed, investigators were astonished to discover an abundance of silicates that only form at super hot temperatures, up to thousands of degrees. A further shock was the presence of so-called impact craters on the comet nucleus. As reported by New Scientist in 2004, that is completely unexpected, because comets are believed to be loose aggregations of dust and ice that would shatter on impact. If the pits are craters, the surface of the comet nucleus must be much stronger than experts thought. NASA's Ray Newburn said of the discovery, "I don't think any of us ever really considered the possibility of impact craters. It may be a well-cemented rubble pile, but it's definitely not a loose, powdery surface." Unfortunately, these revelations only led to ad hoc speculations about Wild 2's history, including astronomically improbable collisions. as well as the suggestion that the comet was flung into the inner solar system at some point in its history, where its hypothetical ices were baked off by the sun, then flung back out. Astronomers were equally stunned by their observations of Wild 2's jets. A press release for the Stardust mission stated, "The team predicted the jets would shoot up for a short distance, and then be dispersed into a halo around Wild 2. Instead, some super speedy jets remained intact, like blasts of water from a powerful garden hose." Mission scientist Dr. Benton Clark stated, "A big surprise was the abundance and behavior of jets of particles shooting up from the comet's surface. We expected a couple of jets, but saw more than 24 in the brief flyby." In fact, over 20 years after the Wild 2 discoveries, comet jets remain as problematic as ever. As described in the scientific paper, Cometary Jet Collimation Without Physical Confinement. Contemporary models postulate that these jets collimate when the expanding gases and dust pass through a physical aperture or nozzle. However, recent high-resolution spacecraft observations fail to detect such apertures on cometary surfaces. These models do not explain why cometary jets appear to be directed normal to the local gravitational potential. This is especially puzzling because the jet velocity, typically 300 meters per second far from the comet, greatly exceeds the escape velocity of only about 1 meter per second. This is all just to give you a small glimpse as to why the discovery of a comet, in the words of a recent Science Alert report, belching out explosive, collimated jets at 1.5 billion miles from the sun is a big theoretical problem for mainstream astronomy. Subliming ices and outgassing did not predict and do not explain the actual observed scientific data. As viewers of this channel have long known, the electric universe offers its own theoretical framework for predicting and explaining comet activity. Comets are not the icy leftovers from the solar system's formation, supposedly 4.5 billion years ago. Rather, they were torn from planets and moons by interplanetary lightning in a relatively recent epoch of planetary instability. Most comet activity is electrical in nature, with the comet producing cathodic jets in response to its rapidly changing plasma environment. In fact, cometary jets were reproduced over a century ago in the laboratory by the renowned experimentalist Christian Birkeland. Typically, this occurs as the, quote, negatively charged comet approaches the sun, although on rare occasions comets can also be seen discharging while moving away from the sun, perhaps when they are struck by solar outbursts or when they pass close to a planet's magnetosphere. The detection of water molecules in the cometary coma is the product of complex electrochemical processes in the comet's dynamic plasma environment. Longtime viewers remember the presentations of Dr. Franklin Anariba, including his talks at various Thunderbolts conferences, in which he outlined his hypothesis of cometary electrochemical water production. Indeed, in recent years, mainstream astronomy has only moved closer to affirming Anariba's hypothesis. As noted in a 2019 press release from the NASA Goddard Space Flight Center, plasma scientists have been showing how electrochemical processes can explain the presence of water in the lunar soil. As plasma physicist William M. Farrell states, "We think of water as this special, magical compound, but here's what's amazing. Every rock has the potential to make water, especially after being irradiated by the solar wind." The press release concludes, "Every exposed body of silica in space, from the moon down to a small dust grain, has the potential to create hydroxyl and thus become a chemical factory for water. We can also add to this the repeated instances in recent years of asteroids producing dramatic outbursts, which conventionally are only expected of comets." Again, all of this is only a short glimpse at the overwhelmingly compelling evidence in favor of the electrical interpretation of comet activity. I recommend that newcomers explore the dozens of hours of videos available in the Thunderbolts Comet, Asteroids, and Meteors playlist. In conclusion, I would like to make my own prediction for the ESA's upcoming 2029 mission called Comet Interceptor, which will seek to photograph and analyze a so-called pristine, ancient comet in unprecedented detail. As with Wild 2 a quarter of a century earlier, Astronomers expect such an object to be covered with abundant water ice, and they have no reason to expect such a comet nucleus to display complex planetary geology. However, we can safely predict that the nucleus of any such comet will bear no resemblance whatsoever to the dirty snowball of standard theory. Instead, like every other comet nucleus imaged to date, it will appear exactly like a piece of planetary material that has been electrically blasted into space. It will appear as such for only one reason. That is exactly what it is.